Hello everyone, welcome to our discussion of section 3.5 where we will talk about solving absolute value equalities and absolute value inequalities. And I remind you that last time we talked about solving rational equations and radical equations. So the absolute value inequality and equalities both feed off of the definition of an absolute value. So first, that's going to be the first thing we will go over, and then after that, we'll go through a bunch of examples. So before that, I want to remind you to please take 30 minutes to 45 minutes to skim through section 3.5 from your textbook, then watch this video and attend the class. And then, as you do that, take a note of the things you see or hear that are important to you, or the things that you might have questions on. Then, the second time, go over all the examples that you saw solved in the book, section 3.5, without looking at the solutions, and try to solve those problems on your own. Then you compare your solutions with that. And then you do the same exact thing with these problems that I'm working out during the video. I will try to remind you, but I might forget. But please, even if I forget, pause the video. Whenever I get to a problem, exercise problem, pause the video, write down your own solution, and then unpause the video and watch the rest of it. Okay? And of course, all of this leads to completing the homework by the due date. And after that, please spend about half an hour a week reviewing the previous material. Just look over your notes in order to refresh your mind about the material that we've already covered. Okay. All right, so absolute value is equalities, as you can see right here. These are some examples, absolute value equalities, and I want to show you some examples on the other page like that. These are absolute value equalities. And then absolute value inequalities, this is what they look. They look like that, right? Like that. These are absolute value inequalities. Both of these types of absolute value equalities and inequalities, both of them feed off of this definition of an absolute value. As a matter of fact, let me put a title on that. So what you see here is the definition of the absolute value. So when we solve for an absolute value expression, whether it's an equality or inequality, the first thing is we need to remove the absolute value notation or symbol. Because absolute value notation, which is those vertical bars on both sides of the x, those are grouping symbols. Yes, they do perform another function beyond grouping what's inside the absolute value, but another function they perform is that they are a grouping symbol, just like a parenthesis, just like a fraction line. So we cannot solve for x unless it's outside of this absolute value symbol. That's where this definition of the absolute value becomes so important, because as you can see, on the other, absolute value of x equals to these two entities which do not include the absolute value notation. Absolute value bar is gone, right? And that's what we want. The other thing you should notice is that as we remove the absolute value, we inevitably end up with two solutions, not one. Okay? So those two things should catch your attention. The fact that when we solve for x within an absolute value expression, we need to remove the absolute value notation. We need to ungroup the x from this notation, absolute value notation. And second, as we do that, we end up with two solutions, not one. The other thing is that this removing of the absolute value is conditioned on the x value. That's why we have f(x) greater than 0, f(x) less than 0. In other words, this is the mathematical way of saying if x is positive and if x is negative. Okay? As a matter of fact, we can put an equality symbol under that too. So if x greater than or equal to 0, then absolute value of x equals to x. All you have to do is just remove the absolute value notation and you get one of the solutions. You get one of the solutions if x is greater than or equal to 0. So we don't know what x is, right? X is a variable. But we have to look at both situations, whether x is positive or equal to 0 or whether x is negative. In either case, we have to look at how the solution will come about. The other condition is that if x is negative, x less than 0 means if x is negative, then you can write absolute value of x as equal to minus x. It has the same effect. It has the same effect as saying, if you have, for example, if you have absolute value of negative 2, right? If x in here is negative 2, you can write this x without the absolute value notation. In other words, you can write minus 2 without that. If you remember to multiply it by a negative 1, minus 2 is positive 2, which is exactly what this absolute value would generate if we had absolute value of negative 2. We'll do plenty of examples, so you see exactly what I mean. Okay? So the important thing, this is a very small property or definition of absolute value, but it's extremely useful and it's extremely important in mathematics. So as we solve absolute value equalities and later inequalities, we need to remove the absolute value notation in order to solve for x. When we do that, we end up with two solutions, not one. One of the solutions is multiplied by negative 1. Do you see it? One solution is just the same thing without the absolute value. The original variable without the absolute value is one of the solutions. The second solution is the expression inside the absolute value multiplied by a negative 1. And then using that, we come up with two solutions. This is so important, I cannot emphasize it enough. If you understand what just happened or what this little box is explaining or showing, you completely understand the rest of this section. That's how important it is. So we need to remove the absolute value, and then we end up with two solutions. One of the solutions is just like the original solution without the absolute value bars. The second solution is the inside multiplied by negative 1. Okay? All right. So let's look at the next properties here. If we have absolute value of x less than a, now this is inequality, right? It's the same thing as above. It's the same thing as absolute value equality, but when we see here, when we multiply the inside by negative 1, the equality is just equality. But inequality, we've learned in previous videos, previous sections, that when you multiply the inequality by negative 1, the inequality will change direction. That's the thing you got to remember. Okay? So that's what this is actually showing. So one solution, how did we get that? If this box is saying if this, then that. So how did we get that? Let's show it. We're gonna show that using the absolute value definition. So one of the solutions, now for a second, disregard that part, okay? Disregard that piece altogether. So let's just focus on this. Suppose we have that. How do we find the solution of an absolute value inequality like that? Well, as we said in the definition of the absolute value, one of the solutions comes from just writing the initial absolute inside of the absolute value in the original form, x less than a, without the absolute value, just like saying absolute value of x equals x without the absolute value bar. So we can say one solution is x less than a, right? Just look, compare that with this. I copied this thing, the original form, just like that, without writing the absolute value. Okay? That's one of the solutions, x less than a. The other solution comes from multiplying this a by -1. But that's also multiplying this inequality by -1. So it will change direction. So we'll have x greater than, right? X greater than minus a. So I'm applying the absolute value definition to an absolute value inequality. Because of this inequality symbol, I have to take into account that when I multiply this side by -1, this inequality will change direction. So we end up with x less than a and x greater than a. Now compare that with this. Isn't this the same thing as this? But this is combining them. This inside the box is combining what I've shown outside the box here. X less than a, x less than a. X greater than minus a, x greater than minus a. So this thing is the same thing as that, but written in a way that is helpful. When we solve inequalities, you'll see that's a helpful way of writing it. But if you prefer it this way, if you understand it this way, that's quite fine. There's nothing wrong with that. I explained it like this because I wanted you guys to see the similarity between absolute value definition and what we do to solve an absolute value inequality. Okay, let's do the same thing here. So this one is different than that, right? This is saying absolute value of x greater than a. So we're going to have two solutions, right? We explained that. According to the absolute value definition, in order to solve for x, we need to remove the absolute value notation, or bars, absolute value bars. And what happens is that as we do that, we end up with two solutions. One is just the original expression inside the absolute value with no change. The second is the inside multiplied by -1, minus x. Okay? We do that here. So one solution will come from the original absolute value inequality written without the absolute value bar. So we get x greater than a. Right? Compare this with that. All I did was remove the absolute value bar. I kept everything else the same. Now the second solution comes from x, the inside of the absolute value, but the other side multiplied by -1. When we do that, this inequality changes direction. So from greater than a, it becomes less than negative a. Okay? So compare this with that. The absolute value bar is gone. Those bars are gone. But instead, what do we have? We have two solutions. X greater than positive a, x less than minus a. Okay? But compare this with that, what I have in the box. Isn't that the same thing? X greater than a, x greater than a. Or x less than a, less than minus a, x less than minus a. Okay? So now, take a look at these. I'm going to put all these 4 problems on the screen so you can see it. You can download the worksheet, of course, but here they are. Write these on a piece of scratch paper, then pause the video, finish solving all 4, then look at my solutions that are coming up. Okay, I'm counting on you that you did that, and now you're back. Okay, so let's solve these. We know that in order to solve absolute value equalities or inequalities, we need to remove the absolute value notation, right? The bars. So, okay, let's do that. So one solution will come from x equals 3/2, written as you see it without the absolute value bars. That's one solution. What about the other solution? The other solution comes from x equals the other side multiplied by -1, so minus 3/2. In each of these, can you test if these solutions are correct or not? Absolutely. So you can plug each of these inside the absolute value and see if in fact that's the solution of that. Okay. Part B. Part B, I don't like to give trick questions during exams, but during the worksheets, these are kind of, I want to see how you answer questions like these. So I do place questions like these on worksheets, but not on exams. I'm not a big fan of these types of questions on an exam. But this is an absolute value set equal to minus 3/5. Is that even possible? No. So this problem has no solution. There's no way we can have an absolute value of something to be equal to minus 3/5, because the absolute value makes the sum of the terms on the inside, the sum of them, a positive number. So how can we have that equal to this? So this one has no solution. Okay? That's that. Part C, it says absolute value of x equals 42. Okay? So one solution, like we said, comes from just rewriting this without the absolute value bars. So x equals 42 is one of those solutions. What's the second solution? The second solution, it's going to be the inside of the absolute value equals, multiply the other side by -1. So negative 42. Okay, that's that. I hope you can see the connection between what we're doing and the definition of the absolute value that we went over in the beginning. And the more of these problems we solve, the more you'll see how important this definition is. As a matter of fact, let me use my highlighter to highlight that. Okay. All right. So next, we have absolute value of 5x equals 4. So we're going to have two solutions, right? One solution is coming from rewriting the whole thing without the absolute value bars. 5x equals 4. The other solution comes from, now we have to solve this, I know. We're not done with this, but I want to show you the other solution path before I come back to this. So one solution path is from rewrite the whole thing as it is, just remove the absolute value bars, like that. The other path to solution is rewrite the inside of the absolute value as it is, equals, multiply the other side by a -1, -4. Okay? So now we're going to solve for x using each path. So from here, because we're solving for x, so x must be isolated, right? Is it isolated? No, it's not. It's got a 5 next to it, right? How do we get rid of the 5? We divide both sides by 5. So we end up with x equals 4/5. Okay? That's one of the solutions. From this path, again, we isolate x by dividing both sides by 5. So we end up with -4/5. Like that. Okay. Okay, there they are again. E, F, and G. Please go ahead, write these down on a piece of scratch paper and solve them before you see my solutions. So now it would be a good idea to pause the video and do all that. Okay, I'm assuming you've done that and now you're back. Okay, so here we have two solutions, right? One solution comes from rewriting the whole equality as it is without the absolute value bars. So x minus 7 equals 5. The other solution will come from write the inside of the absolute value as it is with no change. Write the equality as it is, but then multiply the other side by a -1. So we end up with -5. Right? -1 times 5 is -5. Okay? Next, let's solve from each path. Let's solve for x. So here, x equals -7 plus 5. So we have 5 plus 7. On this side, it's -7, right? When I move it to the other side, it becomes +7. So x equals 12. That's one of the solutions. You can test it if you like. Then this one, x equals -5. Move the -7 to the other side, it becomes +7. Then combine that with this. 7 minus 5 is 2. +2, right? Like that. So those are the solutions of that. Do you have to check these? No. If you've done these, I mean, you can check them, but if you've done, you don't have to. If you've done everything correct, these numbers must be correct. It's not like the radical expressions and the rational expressions which we saw in the previous video in section 3.4. This is not like that. Those, it doesn't matter if your solution is correct. You must check the final answer. Here, it's optional. Once you have your solutions, if you have doubts, you can check if you like. If not, you don't check. Okay, but the steps, if you have time, say during an exam, you should check these numbers. Okay, so part F, by the way, I hope these answers match what you wrote down in your own as you watch this video. Okay, so this one. The thing here is to make sure that the constants are on the other side. So that's the first thing I would do. Absolute value of x plus 2 equals 9 plus 5, right? Move the -5 to the other side. It was negative on this side. When you move it, it becomes +5. So then we have absolute value of x plus 2 equals 14. So how do we go from here? Where do we go from here? Okay, well, just like before, we're going to end up with two solution paths, right? Let's write each one down. One solution path comes from rewriting all of this exactly as it is without the absolute value bars. So x plus 2 equals 14. The other solution path comes from rewriting the inside the absolute value as it is, equals, multiply the other side by -1. So we get minus 14. Okay. Now let's solve for x from each path. So here we have x equals 12. Right? 14 minus 2. Move the 2 to the other side, you get minus 2, 14 minus 2, which is 12. Like that. Here, we have x plus 2 minus 14. Okay, so x equals minus 14 minus 2. Move the positive 2 to the other side. It becomes minus 2. Okay, so we have x equals minus 16. Like that. Okay, so if you wish, you can test that. You can plug in there and test that. Okay, so I hope these two answers also agree with your own solutions. This one, once again, the purpose is to isolate the absolute value term here, which is absolute value of x minus 2. We need to isolate it. Is it isolated now? No. It's got a minus 1 in front. It's got a 9 before that. So it's far from being isolated. So let's isolate this. What I would do is move the absolute value to the other side. We can do that. Or you can keep it on this side and move the 9, whichever. So we can, let's do that first. So minus absolute value of x minus 2 equals 7 minus 9, right? What I did was move the 9 to the other side. Now it's a little bit better. Let's simplify. Minus absolute value of x minus 2 equals minus 2, right, on the other side. So now we have minus and minus on both sides. We can cancel them. So we can write absolute value of x minus 2 equals 2. This is exactly like as if you have minus 1 multiplied by this, minus 1 multiplied by 2. So can you simplify minus 1 from both sides? Can you cancel it? Yes, you can. Why? Because minus 1 is being multiplied on both sides. It's not being added or subtracted. So we end up with that. Now, how do we arrive at the solution? As you've seen so far, we need to look at two solutions. Right? One solution comes from exactly the same absolute value equality written exactly like that, but without the absolute value bars. So x minus 2 equals 2. Right? When you compare it, those are very similar, except the absolute value bars are gone. So one solution comes from that path. The second solution comes from this equation. Let's rewrite everything that is on the inside of the absolute value as it is. So x minus 2, then equality, then multiply the second, the other side by minus 1. So minus 2. Okay. All right, so let's solve for x using each path. This one, x minus 2 equals 2 becomes x equals 2 plus 2. This plus 2 is that one. It was minus 2 on the left. When I moved it to the right side of the equality, it changed the algebraic sign, plus 2. It's always like that. You can move things around both sides of the equality or inequality, but you got to remember to change their algebraic sign. That's all. So from here, we see that x equals 4, right? And from here, we can see that x equals minus 2 plus 2, or x equals 0. Again, that positive 2 is this negative 2, which we move to the other side and it becomes positive. Okay? All right. I hope this is going well and everything is agreeing with your own solutions. Okay, so next it says solve the following inequalities and write the solution set using the interval notation. That's very interesting. Why? Well, first, so now we're making the transition, right? We were solving absolute value equalities, but now we're making the jump to absolute value inequalities, right? It's different, but it's similar at the same time. You'll see in which ways it is different and in which ways it is similar. But let me ask you this. Why, before, when we were solving absolute value equalities, the question didn't ask for us to put the answer in using the interval notation, but here they're asking that. What is the reason? How come all of a sudden we get a question like this when the previous one didn't ask for that? Well, the reason is with absolute value equalities, you can have just a finite number of answers or solutions. One, maybe two, or two, maybe one. Either way, right? It's finite, one or two. But with absolute value inequalities, if there is a solution, you have infinitely many solutions. But it's just that which infinity? Okay, because real number line can be segmented into infinitely many numbered intervals. Okay, so we can do that with the real number line. Segmented into infinitely many intervals, each interval having infinitely many numbers in it. Okay, such as 0 to 1, right? There is a mathematical proof for the interval from 0 to 1 containing infinitely many numbers. So that's why we want to use interval notation. In this case, we cannot afford not to do that. We must use interval notation to give the answer, okay? Because there are infinitely many solutions here when we have solution. Okay, so it says solve these inequalities and write the answer using the interval notation. Let's do that here. We're going to apply the absolute value definition again. The only thing you got to remember here is that when we go with this one, the second solution, when we multiply the other side by -1, when you do that with inequalities, the inequality will change direction for that solution. Remember, we have two solutions, right, for each absolute value equality or inequality. For the absolute value inequality, the solution path that has the right side multiplied by -1 must have its inequality symbol swap or change in direction. Okay, what do I mean? Here's what I mean. Okay, so we have two solution paths. One is the same inequality with no change, except that the absolute value bars must be gone. So x less than 3. Okay, that's one of the solutions. Then the other one said this. Write the x as it is without the absolute value, multiply the other side by -1, so we have -3, but that means that you have to multiply this symbol by -1 too, so it'll flip or change direction. Okay, so this is x less than 3, x greater than -3. So the solution from that is x greater than -3, just like that, and less than 3, just like that. Okay? So it's the place where these two overlap. They're not asking us to graph this. Well, and also I have to give this using the interval notation. So let me do that here. And the interval notation would be parenthesis, -3, comma 3, parenthesis, right? Parenthesis means that 3 and -3 are not included as part of the solution. Why aren't they included? Why are they not included? Well, because here, the left side cannot be equal to 3. It can only be less, absolute value of it can be only less than 3. Okay, and that can happen if x is within this interval. So this is the interval notation. Okay, like that. Can we look at this on a graph line? Absolutely. So suppose we have -infinity to infinity, 0 in the middle, and what we ended up here with is, well, let's look at the individual solutions, and then we'll find the overlapping region. So x, let me mark this off with 1, 2, 3. So we have 3 here and -3 here, right? So this solution says, hey, x has to be less than 3. So that means that. That means x has to be this way, right? Less than 3. And let me put a hollow circle there. That's what this is saying. The other solution says, no, x has to be greater than -3. So this way. So this solution goes this way, excluding 3. This solution goes that way, excluding -3. Okay? Where they overlap is the solution. So which is what we have shown here in parentheses and the interval, and using these symbols, inequality symbols. But this is the solution piece. Okay, like that. Okay, this is part B. I hope you've done this on your scratch paper, right? So this one, again, one of the solutions comes from the original inequality written with no change. Just the absolute value bars are gone. So x greater than or equal to 2. And the other one comes from the inside of the absolute value, the other side minus 2. Oh, but wait a minute. If we multiply the other side by -1 to make it -2, then this inequality has to change direction. So from that, it becomes that. Okay? So the solution of this is x must be greater than or equal to 2 or less than or equal to -2. Okay? So what is the solution then? Let's graph it and see. This is not the, we have the individual solutions figured out, but not the final solution yet. So let's graph. We don't have to graph, but I'm doing it to make sure that everybody sees what's going on. -2, that's -2, suppose, and this is 2. Okay, so this solution, this one, says x must be greater than or equal to 2. That means go this way. Right? X greater than or equal to 2 is that. This one says no, x has to be less than or equal to -2. So this says go this way. So what's the solution then? The solution is the union of those two pieces. So if here, so it's this or that. Let me put that, this or that. Okay? So if the solutions overlap, like they did in part A, then the overlapping piece is the final solution. -3, 3 in numbers and graphically like that, and here's symbolically like that. Okay? Once again, in absolute value inequalities, if the individual solutions overlap, then the overlapping piece is the final solution. The one that I've boxed here and I've shown here on the graph. Of course, each of these solutions is much more than the overlapping piece, right? This is any x value less than 3. That one is any x value greater than -3. But the two solutions overlap in this region, and that's the final solution. That's if the individual solutions do overlap. But what about if they don't overlap, like this? Then the solution is the union of the two. So this side is a solution. Either this side is the solution, that side, or that side. Oops, like that. All right, so let's write down what the solution should be using interval notation, which is what they're asking us. Okay, using the interval notation, we have -∞ to -2, parenthesis or bracket. If you said bracket, you're 100% correct. Bracket because -2 is, look at the equality, is part of the solution. Union, that piece. Bracket, 2 comma, infinity, parentheses. And the infinity side always gets the parentheses. Okay, and we write these numbers always with the smallest number on the left, comma, the larger number on the right. Okay, I hope this is making sense as we're going through it. So here we are. Let's start with these two. Please write these down on your paper. Then solve them. Pause the video first, write these down, solve them, and then come back to the video to see my solutions. Okay, so here we have two solutions to work with, right? One solution comes from the original inequality as is, except remove the bars. So 5x less than or equal to 4. The other solution comes from the inside of the absolute value written, multiply the other side by -1, so we get -4. But hey, don't forget to change this to the opposite direction. The other side got multiplied by -1, so this has to change direction to the opposite, like that. Okay, so let's solve for x using each path. So this, x needs to get isolated, right? It's got a 5 next to it. We need to get rid of the 5, so divide both sides by 5. So x less than or equal to 5 or 4 over 5. Okay, so that's the solution from this piece. From this piece, again, divide both sides by 5. We get x greater than or equal to -4 divided by 5. Here's the second solution, right? So what's the final solution? Because we need to give that using the interval notation. So let's do a little graph here. -∞, infinity, 0 in the middle. So 4/5 is a little bit less than 1, right? If this is 1, then 4/5 would be here. And I'm going to put a filled in circle because this 4/5 can be part of the solution. 4/5. X greater than or equal to, so this solution, and well, let me plot this and then I'll go over that too. So and if this is -1, -4/5 would be somewhere here, -4 over 5. So this solution says x is equal to or less than 4/5. That means it is going this way. That solution is that, this way. This one says, no, x should be any value that is equal to or greater than negative 4/5. So this one says we got to go this way, not that way, this way. So where is the final solution? The final solution is the overlapping piece, because these two solutions do overlap. If they don't overlap, like the previous example, we're going to take the union. But if they do overlap, the union is the overlapping piece is the solution. So we have bracket negative 4/5, comma, positive 4/5, close bracket. And this is our final solution shown in using interval notation. Can you test this? Absolutely. You can just test it right there. You can plug numbers within this interval there, like 0. 0 times 5 is 0. Is absolute value of 0 less than or equal to 4? Absolutely, yes. Or you can test a number outside of this interval, and it should not work, right? Such as 1. 1 and negative 1 are outside of this. So let's plug in 1 for x. 5 times 1 is 5. Is 5 less than or equal to 4? No. So it didn't work out, and it shouldn't, because 1 is not part of this solution. Okay? So this one. Once again, we have two solution paths. One is the original inequality written as it is without the absolute value. So x plus 6 less than or equal to 10. Okay? Without the absolute value bars. The other one, x plus 6, the other side is going to be multiplied by negative 1. So, right, we're going to get minus 10 or minus, I want to highlight the minus here. So the other side gets multiplied by minus 1. So it becomes minus 10 now. But that means this inequality should change direction. So it becomes like that. Okay? So now let's solve for x using each path. So this is x less than or equal to 4, right? Put 6 on the other side, subtract. 10 minus 6 is 4. So that's one of the solutions. The other solution says x greater than or equal to minus 16, right? If you put the 6 to the other side, it becomes minus 6. Minus 6 and minus 10, minus 16. So this is another solution. Okay? All right. So now, what's the final solution then? Let's graph to get a better idea. Okay? Just for the sake of understanding this better. So 4, let's say 4 is somewhere here, and I'm going to make it a filled in circle, because this is x equal to 4 is a solution, right? And negative 16, let's say that's that. So this is 4, this is negative 16. Okay, so this one says anything equal to or less than 4. So it says go this way. This one says no, anything greater than or equal to negative 16. So it says go this way. So where is the final solution? The final solution, because the solutions, individual solutions overlap, is the overlapping region. So this is the final solution. So let's write it using the interval notation. It is bracket negative 16 comma 4 close bracket. Right? That's the solution of that. This one, so I hope that agrees with what you got on your own paper. So this one, same story, right? We're going to have to remove the absolute value to solve this. And when we do that, we end up with two solution paths. One solution path is the same thing without the absolute value bar. So 3x plus 4 less than 13. Notice the answer cannot be, this side cannot be equal to 13, right? That's what we call strict inequality. So that's one of the solution paths. The other one, we write the inside of the absolute value as it is, The other side, the 13, must be multiplied by -1. So minus 13, but if we do that, this is an inequality. So this inequality should change direction. So it'll go like that now, right? It was like that, now it goes like this. Greater, 3x plus 4 greater than -13, which is that. Okay, great. Now, let's solve for each side here. So 3x less than 9, right? Because when you move the 4 to the other side, it becomes minus 4. So 13 minus 4 is 9. If you rather, let me do it this way. Let me not skip that step. Maybe some of you like to see it. 13 minus 4, right? I just moved the 4 to the other side. The positive became negative. Then we have 3x less than 9, right? 13 minus 4 is 9. And then we're isolating x. Is x isolated? No, it's got a 3 next to it. So we need to get rid of that 3. What do? Divide both sides by 3. As we divide both sides by 3, should this inequality change direction to opposite? No. Why not? Because 3 is not, dividing by 3 is not dividing by a negative number. It's just positive 3. So this inequality stays as it is. Instead, we end up with x less than 3. Okay, so that's one of the solutions, but we're not done, as you know, right? So let's solve for x using this inequality. We have 3x greater than minus 13. Move the positive 4 to the other side, it becomes negative 4. Then 3x greater than negative 17, right? Then x greater than, we need to isolate x, right? So divide both sides by 3. Minus 17 over 3. Like that. So what's the final solution? Well, let's make use of a graph to better understand how the solution works. If you don't like to draw the graph, you do not have to. This is just to make this a visual thing, so that those who learn better visually can follow what is happening. But you don't really have to need the graph. So 3 would be somewhere here, like that. And I'm going to put a hollow circle there because x cannot be equal to 3. So that's 3. And then this is x, this is negative 17 over 3. 17 over 3 is a little bit over 5, right? So 5 something. And so, but this is negative 5, so negative 1, negative 2, negative 3, negative 4, negative 5. So that's negative 5, and this is negative 6. So negative 17 over 3 is somewhere here, somewhere there. I meant to, well, let me use my thick marker to put a hollow circle here. That's a hollow circle. This is a hollow circle like that. Okay? Not a filled-in circle. This is a strict inequality as is this one. So it must be a hollow circle. Okay, so let's see. This one says x must be any number less than 3. In other words, they're saying go this way, right? This one says x greater than negative 17 over 3. So this is saying, and if this is, so that point is negative 17 over 3, and this is saying go this way, right? Do they overlap? Do the individual solutions overlap? Yes, they do. They do overlap right here. Okay, so that's where they overlap. Now let's write down the solution using the interval notation, and I'm going to do it here because I'm running out of space. This one is at the bottom here. Okay, so the interval notation for this would be brackets or parentheses. Which one? If you said parentheses, you're 100% correct. It should be parentheses because we cannot be equal to 3 or negative 17 over 3, right? There's no equality symbol under these two symbols. So we have parenthesis, negative 17 over 3, comma 3, close parentheses. So the smaller number always comes first, comma, the larger number, which is, the smaller number being negative number, I mean. Okay, negative number first, then comma the positive number. Okay, so this one, the same thing. Let's split this into two solution paths. One of them is 3x plus 5 less than 0, right? Exactly as that is, without the absolute value bars. Everything removed. Then, if we solve using this path, what do we get? We get 3x less than negative 5, right? I moved the positive 5 to the other side. It became negative 5. And then from here, we get x. We're isolating x, which means we're solving for x. So is x isolated? No, it's got a 3 next to it. So let's divide both sides by 3, positive 3. What do we get? We get x less than minus 5/3. Okay, so that's one of the solutions. The other solution will come from this, the inside of the absolute value as it is. The 0, you multiply 0 by negative 1, what do you get? You get 0. But don't forget that that means we're still multiplying negative 1 by this inequality symbol too. So that one is going to change directions. Or change direction. It was absolute value less than 0. Now it becomes that quantity greater than 0. Okay? So let's solve for x here. 3x greater than negative 5. And then x is greater than minus 5. Let's see, minus 5/3. Okay, so, so this is one of those questions again. But in any case, we end up with the same thing, right? I'm sure a lot of you were much smarter than me, and you saw that this is not possible, right? How can absolute value be less than 0 and be a negative number? So not possible. So right away, you could say that this is not possible. And you'd be smarter than me if you said that. But look at that. Now we have an x less than negative 5/3 and greater than negative 5/3. How can that be? So compare these two. Not possible. You can't be greater than or equal to greater than and smaller than the same value. You cannot. So not possible. So did you have to, if you realize that this is not possible, because absolute value is never negative, and that means that's suggesting that absolute value should be negative. If you saw that, could you avoid this and just write not possible? Yes, you could. You'd get full credit if you did that. But if you went through it and you did everything correct, you could see that that's not possible anyway. Okay? All right. On the next page, we have something. It's absolute value inequality, but we've got fractions involved, right? No sweat. It's the same procedure. How is that? This is how. So we have x plus 3/4 less than 1/4, right? So just rewrite the whole thing without the absolute value bars. One of the solutions comes from that. The other solution comes from multiplying the other side by -1 and making sure that you remember that to switch this to the other, to switch directions on the inequality symbol. So we have x plus 3/4. The other side becomes negative 1/4, right? Negative 1/4. So what happens to the inequality symbol? It'll switch directions like that. Okay? So now let's solve for x using each path. So on this side, we have x less than 1/4 minus 3/4, right? 3/4, we're solving for x, so we're isolating it. The 3/4 was positive on this side. When I move it to the other side, it becomes negative 3/4, right? And we already have the common denominator, so we can subtract the numerators. 1 minus 3 is minus 2, and then x less than minus 1/2. So that's one of the solutions. What's the other solution? The other solution comes from this. X greater than negative 1/4. Move the 3/4 to the other side. It was positive on the left. When it moves to the right side, it becomes negative, right? Minus 3/4. So we get x greater than, we have a common denominator, so we can subtract or add the numerators. Minus 1, minus 3, so minus 4, and that is negative 1, right? So what's the final solution for this? Well, let's draw a real number line. So one of the solutions is less than negative 1/2. So let's put, if this is negative 1, and I'm going to put a hollow circle here because neither solution has equality under it, which means we cannot be equal to negative 1/2 when we cannot be equal to negative 1. So negative 1, and then negative 1/2 would be somewhere here. So this solution is saying anything less than negative 1/2. That means go this way. Go this way. That one says anything greater than negative 1. So it's saying go that way. Do they overlap? They do, right? So the overlapping piece becomes the final solution. Like that. So when I'm ready to write my final solution using the interval notation, should I use parentheses or brackets? Are negative 1/2 and negative 1 included? No, they're not. So we must use parentheses. And the smaller number comes first. So minus 1, comma, negative 1/2. And that's the interval notation, using the parentheses, not brackets. To ensure, right, we use the parentheses to ensure that negative 1 and negative 1/2 are excluded from the solution, and any number between them. And there are, of course, infinitely many numbers between those two. All right, so please make sure that you solve this one and the one underneath it. You can see both on the screen now. So write these down and then pause the video and write down your own solution and then come back and compare. Okay, so once again, we have two solution paths, right? One solution path is exactly that as it is without the absolute value bars. So 2x minus 1 divided by 3 greater than or equal to 5/6, right? That's one of the paths, solution paths. What's the other one? The other one is the inside of the absolute value as it is, 2x minus 1 over 3. The other side gets multiplied by negative 1, so minus 5/6. Because of that, the inequality symbol will change direction, right? It's now that, so it'll change to that. Okay? All right. So now we can then solve this using the methods we used to get rid of the fractions from both sides at once, right? So we multiply both sides by the LCD. Remember the last, I believe it was the last video. So the LCD here is 6. Multiply both sides by 6 then, right? Not different numbers, guys. So 6 multiplied by 2x minus 1, and it's a positive number, so the direction of the inequality is preserved, like that, greater than or equal to 6 times 5/6, right? So then we have 3 goes away, 6 has a 3 factor, so that goes away, we're left with 2. So on the left, and we have 1 here. So 2 times 2x minus 1. 2 times 2x minus 1. Greater than or equal to, the 6 and the 6 cancel each other out. We end up with 5, right? So let's distribute. 2 times 2x is 4x. 2 times minus 1 is minus 2. Greater than or equal to 5. So this is a linear inequality, right? We can easily solve this. So let's write down that. So, okay. So we have 4x greater than or equal to 7, right? Move the negative 2 to the other side, it becomes positive 2. Add it to 5, you get 7. So one more step, because x is not isolated yet, right? It's got a 4 next to it. So we got to divide both sides by 4. So when we do that, we end up with x greater than or equal to 7/4. So that's one of the solutions. Half of the solution, but this half we are not finished with, right? So let's find what that is. So once again, the LCD for both sides is 6, right? Just like what we did on this side. Multiply both sides by 6. Like that. Okay. So then 3 goes away, we have 1. 6 has a factor 3, which goes away with this. We're left with 2 here, right? So once again, we have 2 times 2x minus 1 less than or equal to 6 times minus 5/6. This 6 and this 6 go away, cancel each other out. We end up with negative 5. So let's distribute the left. 2 times 2x, 4x. 2 times minus 1, minus 2. Less than or equal to negative 5. So then 4x, I'm running out of space here, sorry about that. So I might have to kind of write the final answer without graphing, because there's no place for me to graph. I might squeeze it in there, but the page would be too crowded if I do. So 4x less than or equal to, move the negative 2 to the other side, it becomes positive 2. Add it to negative 5. Negative 5 plus 2, we get negative 3. So then from here, x is less than or equal to negative 3/4. So this is the other half of the solution. So what is the final solution using the interval notation? I'm going to skip drawing a graph for this, but you guys at home or wherever you're watching this, you can, on a piece of paper, just draw the graph. Make sure that the final answer makes sense to you. And if it doesn't, please bring your questions up to me. Okay, so writing this one says x greater than or equal to 7/4. This is less than negative 3/4. Do they overlap? Do the individual, well, I'm not going to draw the graph here, but I can draw it on a piece of scratch paper. It just occurred to me. Yeah, okay, right here. So let's draw the graph. the solutions do not overlap, right? Do you see that? So let's say minus 3/4 is somewhere here, and I'm going to put a filled in circle, minus 3/4, and 7/4 is, let's say, somewhere here. And again, filled in circle because we have equality. So both of these are going to be part of the solution. So 7/4. Okay? So let's look at individual answers. X greater than or equal to 7/4, that means the solution must be going that way. Right? X being less than or equal to negative 3/4, so this solution says, no, that's not the solution. The solution is this way. Okay? Do they overlap? No, they do not. So what is the final solution then? The final solution is the union of these two individual solutions that do not overlap. If they do overlap, we write down the overlapping piece, but in this case they do not. So the interval solution, I'm going to write it here and then I'm going to write it on the main piece of paper that we have here. So the final solution using interval notation would be negative infinity, comma, negative 3/4, parenthesis or bracket. If you said bracket, wonderful. That means you didn't forget that we have equality here. Here. Equality here. Okay? So then union, right? This union, that piece, means either this piece or that piece. So then we have bracket 7/4, right? Comma, positive infinity. All right, so let me write that here. We have minus infinity to minus 3/4 bracket union bracket 7/4 times infinity. Like that. Okay. Most importantly, all of this should make sense to you. The reason I say this, because if this stuff doesn't make sense, you might think of memorizing all this, trying to just memorize how this goes and try to remember it that way. But if it makes sense, you will memorize very, very little, or you have to memorize very little in order to get these answers. For example, you have to both understand and memorize the absolute value definition, right? The one that we talked about earlier on the first page, that one. You must memorize this and understand what it's saying, okay? Which is, to solve for x, you need to remove the absolute value. As you do that, you end up with two solutions, one of which is multiplied by -1. So you got to remember that. All right, but once you remember that, the rest of this is just doing exactly what that definition is saying. Okay, here it says absolute value of this quantity greater than or equal to -1/2. So the one solution path comes from all of this as it is without the absolute value bars. So 2x plus 1 greater than -1/2. Okay. The second solution path comes from 2x plus 1, which is the quantity inside the absolute value, multiply the other side by -1. What do you get? You get +1/2. So you get +1/2 on the other side. And then this inequality symbol will change direction to its opposite. So it's going to switch to that. From that to that. And -1/2 gets multiplied by -1 and becomes +1/2. Okay? That's just what you see me having done so far is exactly what the absolute value definition is. Okay? I'm following the definition. All right, so the rest of this is 2x greater than minus 1/2. Move the positive 1 to the other side, you get minus 1. And then we have 2x greater than minus 3/2. And then multiply both sides by 2. What do you get? You get 4x greater than negative 3. Right? Multiply both sides by 2 to get rid of this fraction. 2 times 2x, 4x. Greater than 2 times minus 3/2, minus 3, because the 2 and the 2 cancel each other out. So then we end up with x greater than minus 3/4. Okay, so that's one of the solutions, half of the solution. The other half comes from the other inequality. So 2x less than 1/2, let's move this positive 1 to the other side. We get minus 1, right? So this is 2x less than minus 1/2. Right? I hope you're following from here to here. I'm just taking the common denominator, right? Let me do it on a piece of scratch paper. We're taking the common denominator. 1/2 minus 1 equals, the denominator of 1 is 1. Now, what's the common denominator as we subtract these? The common denominator is 2, right? So this fraction is okay because it's got a denominator which agrees with the common denominator. We don't have to do anything to this fraction. How about this one? Well, that one is a different story. We got to multiply the denominator by 2, right? But can we do that and not do the same thing to the numerator? No, so multiply that by 2 as well. What do we end up with? We end up with two fractions that have common denominator 2. So that means we can subtract the numerators. 1 minus 1 times 2, 2. So we end up with 1 minus 2 is minus 1 over 2 as a result. Okay? Which is that. So now, once again, multiply by both sides by 2. Right? I didn't show it here. Let me show it on this side. The space here is very limited. So 2 times 2x less than 2 times minus 1/2. So now 2 times 2x is 4x less than 2 times minus 1/2. This 2 and this 2 cancel. We get minus 1. So x is less than minus 1/4. Right? To isolate x, we divide both sides by 4. So those are the individual solutions. But do they overlap? What do you think? Minus 3/4 and less than minus 1/4. Do they overlap? They should, right? Let's see it. On my scratch paper, we could do it. Here, I don't have enough space, but on the scratch paper, let's do it here. Okay, so we're going to show this graphically. All right, so let's suppose this is negative 1, right? Let's say that's negative 1. Then negative 3/4 is right here, and because there's no equality under this, I'm going to put a hollow circle here and say that's negative 3/4, right? Right before negative 1. Negative 1/4 is a larger negative number than this, so it will be on the right side of negative 3/4. So this will be, let's say that hollow circle is negative 1/4. Okay, so this one says x must be greater than negative 3/4. That means everything on that side is included. This one says no, x should be less than negative 1/4. So anything on that side should be included. Do they overlap? They sure do, right? They sure do. Right here, they overlap in this small piece. Okay? So because they overlap, then the final solution is the overlapping piece. So before I write down the interval notation, should I use parentheses or brackets? Which one? Parentheses, right? Why? Because there is no, the x value is not, cannot be equal to that or this value. So we must have put parentheses to indicate that, and I've shown it graphically with these hollow circles. So the final solution would be the smaller number first, right? So minus 3/4, comma, minus 1/4, parenthesis. Right? That's the final solution. Let's write it on the paper there. So using this solution and that solution, we end up with parenthesis, negative 3/4, comma, negative 1/4, close parenthesis. Like that. Okay, and that's that. Okay, we have come to the conclusion of another one of these sections. I hope this helped answer any questions you may have had. If not, please let me know. So thank you for persisting through this video again. And for now, have a nice day, and I'll see you all again later.